All right, so far we're talking to Sharad and Nalini and Pierre and Ali. They're all professors. I'm the first student probably that you're talking to. I hope they treated you nice though. If not, don't worry, we will treat you much better in the evening. We're going to a nice dinner and then to the pub. Okay, so I was asked as a grad student to talk to you about, at least show you the perspective of how it looks like to do research from a student point of view, how a thesis is built here. And my thesis topic is mostly focused on personalized location modeling. Now again, sorry, my name is Moshe Lichman. She presented me already. I'm a fourth year student here. I work in the machine learning group with Porrick Smith, who's my advisor. Okay, so let's talk about this. So what exactly do I mean when I say personalized location modeling? Now the best way to explain that is to break it into two parts and explain each one on its own. And I'm going to start with location modeling. Now, when I say location modeling, what I mean is that if I have a lot of information, doesn't have to be a lot, but let's assume we do, on specific location and the people that visit those locations, what question can I answer about these locations or these people? For example, let's assume what we see here is the map of Laguna Beach, which is about 30 minutes south of here. And once you'll accept the offer from UCI, I'm assuming that you all are going to accept that offer, you will probably go to visit there because it's a really nice place. People jump from cliffs to the water, surfing, art stuff. If you like art, I don't. And every month, actually, every full moon, there's a group of fire spinners spin fire in the beach there, which is kind of nice to go to see. Anyway, so we see this map, and all these red dots are actually tweets from people at that location. Each one of these dots is a specific individual at that specific location. And one of the questions that people can ask is, for example, where the hell is my brother? Now, I am kind of sad that no one gets that reference. You need to watch more movies. So what are the chances that my brother is actually there? Yes, no, with some numbers. So that's one question. Another question that people like to answer is, if I give you this set of location, now we're talking about all these areas with the dark border and blue shade in it, and I show this histogram here on the bottom left, where you can see the number of tweets, or you can see the number of people, you can correlate it with that, during the time of day over 24 hours window, over like a week-long period. And we can see the seasonality. What can we say about these locations? What are they used for? What's their functionality? Now, you can't read any of this because it's too small and good, because I want to ask you not to read it. But just guess for a second. If you see something like this, during weekdays in the morning, we have high peak, and then it just goes down during the evening. What could it be? Someone whispered schools, and he was right. So these are all schools area in Tustin, which is also pretty close. Those of you who are local know that area. And we see that during the morning between 9 and 12, there's a big surge of number of tweets, and it kind of dies out during the evening and during the weekend. There are still some tweets during the weekend because they also have basketball courts, soccer, I don't know what else, and things are used during the weekend as well, but just not as much. Okay, so the other part of the title was personalized. What do I mean by personalized? Now, in order to explain that, we need to briefly just look at what other people are doing when they're doing location modeling. Now, most of the work these days focuses on data sets such as Yelp and Foursquare, where we have all these public domain places like pubs, restaurant, hardware store, whatever you want on Yelp or Foursquare, and people just check in there, say, we were there, Yelp, they write a review, but there's like a hidden assumption says if you wrote a review, you went to that place. I don't know if it's fair or not. I don't have many reviews on Yelp. I definitely didn't go to any of the places that I wrote reviews for. So we have this type of data kind of constrains us to these public domain places. So I can only answer a question about who's going to this pub, who's going to this restaurant, and it's useful for the type of work that they're doing because they're saying, I want to find the best place to recommend for you to go next. What restaurant? If I know the restaurant you went to in the past, and I kind of have some sense of what food you like to eat, which restaurant you would like to go next, stuff like that. However, you can imagine that this type of data limits the information that we have for each individual on its personal life, where he lives, where he likes to go when it's not a public domain, where like when you leave the house, when you go to smoke your cigarette, because you're not allowed to smoke inside the house, things like that. And that's where the personalized part takes place. Like I wanna shed the light on these specific areas, on these specific data sets where I don't care about this, I do, but not as much the public domain, but more about this personal domain. And to do that, we can use data set from Twitter where we have people can tweet, and it's not necessarily relevant to the place. I can tweet whatever I want, wherever I want. It's not necessarily tied together, so the data is a little bit more complete. Or if you really want to go big brother on this thing, attach a GPS tracker to people, and there are data sets like that. And then you have 24 hours, all the time you know where they are, what they're doing. Kind of creepy, but those data sets do exist out there. All right. So the next thing that should come to your mind is why. Why am I focusing on that? What question can I answer without that I can answer with the Yelp or the Foursquare, all these kind of public domain data sets? And the best way for me to answer that is to show you examples. I will do that a lot during this talk. I love examples. That's how I learn the best. Now, the first example is obviously what you all think about, kind of Big Brother-y style application, whether it's directed advertising that we all hate, but hey, it pays the bills here, so can't hate it too much. Or even straight up surveillance. I've seen military application when they use kind of location modeling to detect where Taliban forces are, which gets kind of creepy at some point. So that thing do exist, and in machine learning, it's something that we always, a lot of us always have in mind. Those applications that I'm creating, those models that I'm doing, all these methods that I'm developing are going to be used for that. Do I want it, or how do I feel about it? And the reason that we're still doing it is because if we put these applications aside, that yes, they pay for the bill, sometimes a lot of the applications are actually using it for really good purposes. And some of the examples are medical sciences, where group of doctors in the CDC or anywhere where they have try to control diseases, they need to know or even create real-time simulation of where people are likely to go in order to control spread of infectious diseases. They do it all the time. Something that is probably more closer to you, fraud detection. Every time you swipe your card somewhere, your credit card, there's a whole system that try to say, is this the real person buying it? Is the owner of the card buying it or not? One part of this system is using location modeling. If you make all your if you live here in Irvine, and you make all your purchases here, and all of a sudden you go to somewhere completely different, something is off there. So not necessarily that will approve that. Urban planning is a more smaller scale application where we just look at the city and we try to figure out how people are using the city. Now I worked on this application with Xerox, where we try to find better way to plan public transportation using that information. If I know where people are going in the city, how they're using it, how can we allocate the resources better? There's also social ecology examples, especially in criminology, when they try to tie where people are going with crime rates and things like that, and many, many more examples. Hopefully you're all convinced by now that this is really important. We want to do this. Obviously I'm biased because my PhD is kind of built on it. So that's that. So that's the why. Now, there are many challenges in this, but I have about 10 minutes to go over them. So I'm just going to show you one key, significant, super important challenge that if you work on spatial data and do location modeling and you're not talking about this, you're doing something wrong. And this is sparsity and variance. Now, what do I mean when I say sparsity and variance? I mean not all people and not all locations are created equal. What we see here in these plots, we'll focus first on the one on the left, so ignore the one on the right, is users in Twitter and the number of tweets we have for them, or equivalent number of locations we've seen them in. Now you can see that a very few number of users have a lot of tweets. And those are usually people, reporter or social media influencers, as they like to call themselves. I don't know what exactly their influence there. And they like to tweet all the time. And if you plot this on the map, you can see even trajectory. It's kind of creepy. You see, oh, this person went to this store and then went to that store. You can see it all the time as if, I don't really know how they just walk and tweet all the time. But most of the users, like you, me, and everyone that I know pretty much, a very low number of tweets, or even more, if you look at Yelp data, it's even more crazy. A lot of people have one review, maybe even not at all. And it makes sense, because most of us are just consumers. Like we look at Yelp because we want to know which restaurant to go to. We probably won't write a review after that, because who has time for this? Now the same thing is also true for location. Very few locations have a lot of number of users in them. So the y-axis represents how many users we saw in that location. So here the most, the dot here is Disneyland in Orange County. Obviously we saw a lot of users go there, but obviously most of the locations are people's houses or things like that. And you have what, 2, 3 people there. If you are talking about Twitter, you might see one, probably won't see any. And that's what we have here, this long, really, really long tail of really small numbers. And that's really where the personalized part kicks in. Because we have location that are specific to user. They're this user's personal location, and it's not shared by other. And this brings a lot of challenges in creating models for this type of data. Now, when we look at it in real-life data, here's an example of Southern California. We are somewhere around here. If I didn't have insane Parkinson, it'd probably be easier to show you. And the red dots represent tweet for a specific user from July 2013, I think, something like that. So this is all the points we thought for our user from July 2013, and they're all around the area of San Bernardino Riverside, kind of inland area. You probably won't visit there if you come here, but if you are local, there's a chance you've been there before. And let's assume we're talking about the prediction problem. I want to say, I know where that person was in July 2013. Where is he likely to go, he or she? I don't remember which one is this. Where is she likely to go in August, in the next month? Now, that's a very fair question, very fair, very used application. You want to predict where that person will go next. So let's do the most simplest thing and say, okay, we've seen that person here. Let's say he's going to go or she's going to go to the same location, or you know what, if not there, maybe somewhere nearby. Which is really fair, because I live here in Verano Place, which you will probably see later in the day on your tour. So I'm either at my home or here or at the grocery store next to my house. I'm not going that far. So if we put this on the map, we get something like this. Now what you see here is called a heat map or a density map or a probability map. Choose the name that you like the most, where more red means higher chances of that person to go there. So we see where we saw all the data before, it's super red, and it just decays to blue as we go farther away from this. Now I had some guiding questions here, but there's not a lot of times we're going to skip it and tell you so as I said, this is fair, because I'm likely to go where I'm going usually or nearby, but something here is a little bit off, and these circles we're supposed to give you the hint. And the idea is that we're given this heat map the same probability, the same chance of that person to go to the middle of the desert here as to downtown LA or even the ocean, which makes no sense whatsoever. So something is a little bit broken there. And that's like where my thesis topic is, where we want to fix this. But how can we fix this? We actually looked at the data. Pierre before said that he can't really look at the data. There's not very interpretability because of the higher dimension. Here we don't. We have 2 dimensions. We have X and Y, so we can look at the data. We can interpret what our model is doing. And we realized that in order to fix this problem, a good way is to bring sources of data from outside, or you can call it contextual data. So let's go over these contextual data types. So the first one is not really contextual, what we talked about. This is the individual data. If I'm going to work and home, I'll probably keep going there. So here's an example. Let's assume I live here and I work here, which is completely not true. Where am I here? I don't even know where. Doesn't matter. So this is there. I'm going to say likely to go there again. But as I said, something was missing. In the map I showed earlier, we said a lot of people go to downtown, no one goes to the desert. How can we use that information as well? Well, we could also look at social information, which is data that can come from somewhere else, and that could be in layers. It could be global population, where everyone's going. Downtown where everyone's going, or similar users, people that may be my friends, where are they going? Because maybe I would probably behave more like them than the global population. And here's an example. Again, this is the map of Orange County. The red dots represent locations that are very popular among all the population, and the star represents locations that are popular for a specific user's friends. Now, the interesting part is that they're not all the time aligned, which makes a lot of sense. I'm just an uber nerd here in computer science in UCI. Global population probably will tell you Disney is the most popular place, but if you look at my friend, the fourth floor here is way more popular than Disney, because that's where we are all the time. Another one is the geographical information. We kind of talked about it, at least one version of it, which saying, hey, if I'm going here, it's likely that I'll go to nearby places. Makes a lot of sense again. A more complex version of it will also incorporate another source of data, another source of metadata that tells me what that location is. And you can think about it this way. If this location is a grocery store, it is very likely that I will go to the one next to my house, while entertainment areas like pub, clubs, things like that, I will be willing to drive farther away for them. So that actually adds more complexity, more interesting part to it, where you use the land use of the data. That's how it's called. The last one is text, which kind of sends us to a different problem, but again, it is other source of data that we can use. And the idea is that if we see a post that you posted on Twitter, Facebook, blog, whatever you want, and it has text in it, the text could help us identify where you are or where you were. So it's kind of a little bit different. I want to say, where was this? So here she talks about, this is a lady from Orange County. She talks about Disneyland. She was there. So I'm assuming I can attach that place to Disneyland, which is here. Another one, which is also interesting, this guy says, I'm staying out. Now these guys, I know if they're female or male. That's why I'm saying that, because I remember their user. Morning, guys, I'm staying home from school again today because I'm sick. Now this is an interesting thing, because he said he's staying home. He gives us some information where he is, but for that we need to know where that person's home is. Now if we did know, which we do, because that person put his home address in the Twitter profile, God knows why, so I can attach his tweet to this area where he lives. And another example, just to fun, I'm going to the beach with my baby. I don't even know how to read this text. I don't know how the people write on Twitter. I'm to the beach Pier 15, so it's probably here. And there are two people there, and also I have proof that she was there because there's a photo. I mean, she could have stole the photo from Google, but I'm assuming she took the photo herself. Okay, so these are all examples of other sources of data that I can bring and combine together in order to enhance personalized location modeling. And one of the cool things that we're doing, so this is very simple, and I'm sure if I've given you enough time, you could have come up with all these ideas yourself. We are finding, what we're doing is we're finding cool principled ways. So we do a lot of math on whiteboards and stuff like that to incorporate that into existing models to make them better. So that's where my research is. And just to, I'm going to move a little bit to more technical part, where it won't be too technical. And I'll show you one example. This is a paper that we published in KDD 2014. KDD is one of the biggest conference for machine learning and data mining. If anyone's going to do machine learning, they'll probably be very familiar with this conference. And in this paper, we only used three of these components. We used the individual data, we used the geographical information, close by, nearby location, and we used social information. Now I'm going to show you a simplified version of this. And the thing to take from it the most is, even though it was super simple, because I talked about text, I talked about metadata, about location, we didn't use any of this. We just used these three things. We are completely destroying any baseline out there. So this is kind of a different approach of machine learning when you look at the data and you're trying to figure out what's going on instead of just black boxing thing. So as the title kind of hints, we use kernel densities for that in order to incorporate all the threes. Now, I'm not going to assume you know kernel density, so I'm just going to give you again an example what kernel density is. Now assume that I live in a one-dimensional world. I can only go right or left. And this is my past data. You saw me in all these locations. And you want to say, okay, I've seen you in these locations, where are you going to be next? So this is July, where are you going to be in August? What kernel density does, it puts a kernel function, that's where the name comes from, which is this little red curve around each point. Now what we see here is that we already have two of the components of those contextual data in this. We get them for free. One of them is the fact that the individual data, we can see that the kernel function is a lot higher exactly on the individual data. So it tells me where you were in the past, this is where I'm going to say you're most likely to go. But if you're not going there, I'm going to say you're going to go to close by location. And the more points you have in that location, the more probability I'm going to give to these close location. So at the end of the day, when you want to compute the probability of going to any place on this one-dimensional world, you just do the average of all these red curves on that specific point. So we can see that place that we went to more likely to go to, the place we went to less. Now we are still missing the social information here. And in order to show you how we can use that, I'm going to go back to this example of the San Bernardino person. And I didn't tell you that before, but this image that you saw was created using kernel density estimation. And now you can kind of see why, because a lot of those curves would be here, so it will be red, and it's going to decay out as far away as we go from it. But again, we had the problem of the desert and downtown LA, so in order to fix that, we can just use the social information. We can look at all the tweets in Southern California in July 2013. Now you can see that they pretty much paint the urban areas, the LA, Orange County, San Diego, even some in Mexico, the road to Vegas. Those tweets are kind of hilarious because they're usually drunk people next to their driver. I hope that they're next to the driver and they're not driving themselves and be like, wee, we're going to Vegas, stuff like that. Or sad if they're coming back. So we can do the same thing with this data. Do kernel density estimation with this type of data, and we get this really cool image, where again, you see the red areas are exactly where the urban population is, and with the highest point downtown LA and downtown San Diego, that's the most likely place to be, apparently. Now, the key part in our paper was that we showed a very nice principled way to combine these two together. That's where the math came. There's also a lot of part of like how many points, blah, blah, blah. If you want to have the full picture, just read the paper. And when you combine these two in our methods, you get this image, which is exactly kind of what I wanted to get. That's what I imagined it would look like. Where I have, again, most of the density, most of the probability will be in the area where we saw all the point in the past, but now the rest of the probability is spread toward the populated areas. So downtown LA now will have a lot more probability than the middle of the desert or the middle of the ocean. That was the cool part. Now, how better this image is? We evaluated it. How did we evaluate? We took July and August 2013. Remember, I told you I had data for July. Now I'm sure that it's 2013, and I wanted to predict August. So what we do in machine learning a lot of the times is very common. We say we know this data, we train this, we use this to build our models, we keep the test data away. We don't look at it until we're done, and then we're testing on the test data and see how well do we predict the test data. One way of measuring that prediction called average log likelihood, where we compute just the log probability of each point of the test point. Now, because it's log, it's going to go negative, and so the x-axis here shows you the 4 different baselines that we used. We used a little bit more than that, and the y-axis show you the actual score. So the higher you are on the y-axis, the better you are. So these are the baselines. They're not doing that great. Again, because again, this is personalized data where people usually don't look, so this is not really fair comparison, because on comparison models that people use on less personalized data, when you have less of that sparsity, so they do better there, but they completely break into personalized data. Now, this is our model, and we are completely destroying the baseline. And when we got the reviews for our paper, people was like, wow, just for the results, your paper should get accepted. We're just completely destroyed everything. Okay, so on this note, on this really nice, look how better we're doing, I'd like to end and thank the people who gave me money, which is the NSF and Xerox that I told you I worked with, and my professor, Porek Smith, and another grad student, Demetrius, who sits there in the back, who really helped me with a lot of this work. All right, thank you. Oh, there's this. So, any questions? Yes.
So it looked, just from what you've got up there, it seems like a lot of these algorithms are isomorphic to something you could use for behavior on the internet.
For what?
Not just for traffic on the internet.
Sure.
As opposed to just, like, you don't have that nice utility map, you can't make your like heat map on the internet really, but a lot of the stuff like prediction of both like individual behavior
Yes.
and the populations, it seems like you could do that on the internet.
Yes.
Have you looked into that?
Yes, we
Okay.
are. We are looking into that.
Good job.